Welcome to Accelerated Math 1. Today we are starting the circle unit. So we're going to go back over some definitions that are important to understand to be able to solve the problems that we have in this unit. Let's take a look at the vocabulary. And this vocabulary is straight out of your text. So if you don't want to copy this down, that's fine. First of all, a circle. A circle is a set of all points in a plane that are equidistant from a given point called the center. And that equidistance ends up being our radius. Okay, the way we would denote a circle, let's say we had circle C here. This is circle C. One way to denote it is to use the circle and the capital letter C. That is circle C. Now our next definition is for a radius. A radius is a segment whose endpoints are the center and any point on the circle. So the radius is the segment that connects the center to a point. And here we have radius. And for our picture, this is radius AC. AC. And if we have a segment, hopefully we remember that a segment is identified with just a bar on top. Now, if it had an arrow at one end, that would mean ray. If it had arrows at two ends, that would mean a line. The next definition we have here is chord. A chord is a segment whose endpoints are on the circle. So we're just looking at from where we have an endpoint on the circle to another endpoint on the circle. On this particular picture, I actually see two chords. I have chord BD, and in this case, it is a segment, if I'm talking about the chord, and I also have a chord BE. Alright, the next one is a diameter. Now if we go back and look at both of these, the diameter is just a chord, but it's a chord that contains the center of the circle. And we go back and look at these, which one contains the center of the circle? Well, that is BE in our picture. A secant is a line that intersects the circle in 2 points. Okay, so we're intersecting the circle in 2 points. Now, one of those points may not continue past that point, but it will intersect in 2 points. So I see a secant BD, and it appears to be a line. So I'll show that it's a line. And I also see the secant BE, and this little line symbol should just cover the top. I extended this last one a little too far. Now, a tangent line. A tangent line in a plane of a circle that intersects the circle in exactly 1 point. And that point is called the point of tangency. A tangent ray and a tangent segment are also called tangents. So I see on circle C, I've done all this with respect to circle C, we have a tangent right here. Do you see the point of tangency is at A? So we have a tangent line AG. Now we could also write that GA, but we need to show it's a tangent line. There appears to be another tangent here at EF. Also a tangent. Now the smaller circle has most of what we've discussed on the larger circle. The smaller circle we can name 2 radii. That would be FH and GH, or we could name it the other way. We also have lines of tangencies. So this AG and EF are common tangents. They are tangents to both of the circles. Theorem 6.1, and we don't have to memorize the Theorem 6.1 part, but it says that in a plane, a line is tangent to the circle if and only if, IFF, what is that telling us? Biconditional. If and only if the line is perpendicular to the radius at the endpoint of the circle. So, since it's if and only if, we could also say the line is perpendicular to a radius at its endpoints on the circle if and only if it's tangent. And at the point of tangency, do you see here's a point of tangency, here's a point of tangency, here's a point of tangency, here's a point of tangency. The radius and the tangent line are perpendicular, 90 degrees. Now, Theorem 6.2 says that tangent segments from a common external point are congruent, and we'll prove that in just a moment. So, let's take a look at what we could do with these problems. I have color coordinated this one to where the radii, the lengths of the radii are in green, and then the green and the blue makes this segment, and then red is a tangent. Now, when we mark that the radius is perpendicular at the point of tangency, do you see we have formed a right triangle? And what would be true about this? A squared plus b squared equals c squared. There's a lot that we could do with this. This is a right triangle, therefore the Pythagorean theorem holds true. A squared plus b squared is equal to c squared. We'll be using that in several of our problems in just a moment. Now, let's look at the next one. What we have are tangents here that are connecting to the radius, and we should know that any radius of a circle has the same measure. All radii of the same circle are congruent, so we know that these are congruent. We can also tell that this is reflexive property here, reflexive property. Now, it says here that tangent segments from a common external point are congruent. So we know that this side is also congruent to this side. Do you see that we have congruent triangles here? Congruent triangles. So, we can, if we had a problem such as this segment must be congruent to this. The radii must be congruent to all other, the radius must be congruent to all other radii. And this segment is congruent to itself, the reflexive property. Since we know the triangles are congruent, we also know that this angle must be congruent to this angle. This angle must be congruent to this angle. And we'll use that in a moment. Take a moment to take any notes from this page that you'd like written. Once again, this is straight from the book. Straight from the book. I do want to make sure you have noticed the notation here. Circle is a capital letter. The radius we're going to write as a segment here, AC. A chord, also a segment. A diameter is also a segment. A tangent can be a line, and I've written these as lines. Tangent can be a line. It could also be a ray or a segment. I wrote these here as lines. Take just a moment to copy down any notes that you'd like, and then we'll move on. Okay. Example 1. Tell how many common tangents the circle has. So common tangents, when we're looking at common tangents, how can we draw a line so that it is tangent to both circles? So I'm going to attempt to do this with my line drawing tool here. Hopefully we can tell, and I'm going to put it on a line. We want it to be tangent to both, so just touch in one point. There's pretty close. Let's see, I think I see another way up here to connect the two. And one point on each circle. That's pretty close. Now, if I drew it through here, it's not touching in one point, it's touching at two. I don't see any other place where I could draw one that would only touch in one point. Okay, so on B, let's start off with the same kind of idea. We already know that this little slant will work. I missed it on the larger circle. I'll try to go back and get that in a second. Okay, and I also think that if I draw it in between the two here, ooh, I missed big time. Let's see if I can rotate that one. Whoop! Got too many things going. I just want that. Just that one. Okay. See if I can shift it or if I just need to start over. I might be able to shrink. Nope, I just want the one. Shrink it just a hair. There we go. That's pretty close. It's not perfect, but it's close. There we go. There's one, and I'll try to draw the last one. Hopefully I'll be more successful. Okay, so we're going through down here, getting both circles. Okay, so not quite on it, but you get the idea. So this would have 4 lines of tangency. Now, our last one is just going to have the 1 line of tangency, and that's going to occur right here. There's only 1 point. Now, sometimes we will not have a line of tangency. We can think of situations where we might have concentric circles, or a circle inside a circle, such as this one. There's no way to connect the two with 1 point, so sometimes you don't even have a common. All right, any questions on common tangents? I will answer on Monday. Take a look at this and do the best you can on today's assignment. Let's take a look at our algebraic examples. Okay, we can tell that AB is a tangent to circle C because it's perpendicular to the radius here. So this is going to form our right triangle, which tells us that A squared plus B squared equals C squared. So in our case, 45 squared plus 108 squared is going to equal X squared. Well, 45 squared plus 108 squared is 13,689. And then we take the square root of that. Now, when you take the square root, you get positive or negative, but because we're talking about a length here, we're only going with the positive. So for this problem, x equals 117. All right, now this one, similar, but a little more difficult. Hold on one moment, I have to get this class settled down. Guys, there's no way they can hear me. Y'all are yelling at each other. Every one of you is within about 2 feet of the person you're talking to. Let's get just normal voice. I'm not even going to say whisper. Just don't yell. Okay, for this one, when we do A squared plus B squared equals C squared, C is this entire length. It's the 49 and the x. So we have to write that as 49 plus x. Here we get x squared plus 63 squared, and 63 squared is 3,969. And then here we square the first, and we get 2,401, double the product, 98x squared. So we're going to move variables to one side, constants to the other, because you should notice that when I subtract the x squared, they're going to cancel. So in this case, I do not have to factor. Sometimes if the square does not cancel, we'd have to set it equal to 0 and factor. So we're going to do the 3,969, subtract the 2,401. That would give us 1,568 is equal to 98x. Divide both sides by 98. And we get 16 equals x. Okay. Our last problem, because we can tell their tangent, they touch at 1 point. We know that these segments must be congruent. That takes us back to the fact that we have congruent triangles here. So this must equal that. The 2x squared plus 3x minus 2 has to equal the 3. Well, this is a quadratic, so we must set it equal to 0 by moving our constant to the other side. Hopefully, pretty good at factoring now. Whoops. 2 only factors to 2 and 1. 5 only factors to 5 and 1. We want the 5 to be positive so that we get the positive 3. So my answer choices are x equals negative 5 halves or x equals 1. We'll have to plug back in and see if that negative 5 gives us a negative length or if it gives us a positive length. So let's test that. So we'll plug that back in, so we get 2 times, when we square it, we're going to get 25 fourths plus negative 15 halves minus 2. So we get 50, this will reduce to 25, so this will make 4 halves. So 25 minus the 19 is 6 halves, which is 3. This is positive. So It is positive. They both work, so those are both solutions to this problem. The last one we're going to look at is an application problem, a word problem. You're standing 14 feet from the edge of a cylindrical water tank and 26 feet from the point of tangency. The tank is 10 feet tall. What is the volume of water in cubic feet? So there's a couple things we want to look at here. One, we need to figure out what this radius is. So let's go on over to the picture. We know that whatever it is here, it's the same thing here. So we know that r squared plus 26 squared has to equal r plus 14 squared. Okay, so we do 26 squared, and that gives us 676. Here we get r squared plus 28r plus 196. The r squares are going to cancel, which is nice. So we do 676 minus the 196. That gives us 480 equals 28r. And divide by 8. Divide by 28, and we get 17.14. Let's just say 17.1 is approximately equal to R. So now we want a volume of a tank, a water tank. It says it's cylindrical, so let's think about our formula for the volume of a cylinder. Volume is the area of the base, big B, times the height. The base is pi r squared. The height. Okay, so now we have solved for R. We can plug that in. 17.1, and it tells us in the problem the height is 10 feet tall. So what we'll do is just punch that in. Pi times 17.1 squared, looks like I left off the squared, times 10. And this gives us an approximate volume, and I got approximately 9,186.3. Okay, now if we had given us more decimal places, or if we had entered this as a fraction, we would have gotten a more exact answer, but we just did an approximation here. All right, now take a look at the problems that are written on the board. You have the remainder of class to work on them. If you do not finish them for homework, and I will check them on Monday. Thank you.